Hello everyone. Today we are going to talk about taming one of the biggest beasts in all of software engineering, scaling your database. We are going to look at how you handle that massive explosive growth without everything just falling apart. So let's dive in. So picture this, your app is an overnight sensation and it has gone completely viral. You are getting millions of people signing up, posting, buying stuff. I mean, it's an absolute dream scenario, right? But then the dream starts to turn into a nightmare. The site gets sluggish, starts crashing, and that one single database server you have is practically glowing red hot, struggling to keep up. And this right here is what we call the scalability wall. It's that ironic moment where your success, all that amazing growth, suddenly becomes your single biggest technical problem. Because let's be real, a single database, no matter how beefy it is, has its own limits. So, how do you, as engineers, smash through that wall? Well, we start by dividing and conquering. And for this, we have a couple of classic tools in our toolkit: partitioning and sharding. Now, they're both about the same core idea, breaking up these giant datasets into smaller, much more manageable chunks. So, let's break down how they actually work. First up, we have partitioning. At its heart, it's a pretty simple idea. You're just chopping up a massive table within a single database, and the goal is super straightforward. When a query comes in, the database has way less data to scan through, which means you get faster results and maintenance also becomes a whole lot easier. You can think of it like putting dividers into a giant messy filing cabinet as shown here. So partitioning, as you see, really comes in two main flavors. With horizontal partitioning on the left, you are splitting the table by its rows. It's kind of like taking a massive phone book and ripping it in half. A to M can go into one book and N to Z can go into the other book. Vertical partitioning on the right hand slices things up by columns. You might put stuff that accessed all the time, like username and email addresses, in one table, and then put the big, bulky, rarely used stuff like user, BIOS, data, etc. in a completely separate one. And that leads us perfectly into sharding. Sharding is a super important point, and it is really just a specific type of horizontal partitioning, but with one absolutely critical difference. Instead of just splitting up a table inside one server, you are splitting all those pieces, those shards across multiple completely separate machines, right? So this is how you truly scale out and handle massive load. But, and this is a big but here, there's a twist in the story. While sharding can sound like the ultimate solution, doing it all by yourself manually can create a whole new universe of pain. It's one of those solutions that often brings its own and sometimes much bigger problems to the table. And don't just take my word for it. This quote from the engineering team over at Twitter just nails the problem perfectly. As they were breaking up their huge ad server, the manual sharding logic that they had built themselves became this enormous bottleneck, an operational nightmare. Let's really dig into their nightmare for a second. And first off, every single service that needed to talk to the database had to have its own copy of this super complex code just to figure out which shard to talk to. Now, this meant if you want to make a simple change, like going from let's say 12 shards to 24 shards, you had to redeploy every single one of those services all at the exact same time. It turned out a tiny change into this massive, all hands on deck, high risk operation. And believe it or not, it even gets worse. It is shockingly easy to shoot yourself in the foot here, as engineers from companies like Google have pointed out things that are totally normal. Best practices, even in a single database, become dangerously anti patterns in a distributed world. For example, using a timestamp or an auto incrementing ID for your key. That means all your brand new data is getting slammed into the exact same shard here, right? So, this creates a situation called hotspot, and hotspots can slow down your entire system, completely defeating the whole point of sharding in the first place. So the bottom line is this: when you are doing manual sharding, your engineering team ends up burning countless hours writing and maintaining all this complex plumbing, routing logic, resharding tools, consistency checks, all this stuff that just feels like the database should be handling on its own. But what if it could? What if the database could just tell you and do it all for you? Well, this is the promise of the more modern solution called distributed SQL. It is designed to take all that pain from manual sharding and just make it disappear. And you can really see the difference here. On the left, you have got manual mess, all this complex logic living in your application, painful resharding, just a huge operational headache, right? And then on the right, you see you have pure elegance of distributed SQL. The database itself handles all the routing, the sharding is totally automatic and invisible to your app, and your application code gets to stay clean, simple, and focused. And the benefits are just huge. You can scale horizontally just by adding more machines. No painful re-architecture is needed. You get incredible uptime, and we are talking about 5 nines of availability because the database automatically handles failure for you. You still get those strong transactional guarantees you would expect from SQL. But maybe most importantly, your developers are finally free to focus on what actually matters, building the product, not managing database plumbing. Okay, so we have covered a ton of ground here. So let's take a deep breath and wrap up all this with a quick recap of the most important ideas we talked about today. So our whole journey started with that scalability wall. We saw that the classic solutions are partitioning and sharding, basically splitting tables horizontally by row or vertically by column, with sharding being the key to spreading those rows across many servers. But then we saw the pain, the manual nightmare that can cause from Twitter's operational mess to those performance killing hotspots. And finally, that led us to the future, automated distributed SQL, which gives you all the incredible power of sharding but with none of the manual headache. And that really brings us to the final questions. As you think about your own projects, about your own systems, ask yourself this: is your architecture built to handle wild success? Are you building something that can scale effortlessly into the future, or just something that's good enough for today? Thank you so much for tuning in. I'll see you again in the next one.